Given that f of x equals x minus 5 over 3 minus x, we want to find these limits. The limit as x approaches 3 from the left, the limit as x approaches 3 from the right, and the limit as x approaches infinity. All right, so we know that the limit as x approaches infinity is used to find the horizontal asymptote. Okay, but why did I pick 3 here for this question? Well, if you look at the function, right, in the denominator, if you plug in a 3 here, we get 0. And we know that for a rational function, that is where the vertical asymptote is going to happen. Right? Now, why do we want to investigate this from the left and from the right? Well, we want to see if the answer is going to be a positive infinity or negative infinity. Okay. So in no particular order here, we'll just start with the limit as x approaches 3 from the left. Right? So 3, the superscript negative of x minus 5 over 3 minus x. So here, what we want to do, right? You can sort of do this mentally, I guess, but you know, what we want to do is we want to start plugging in some numbers here, right? So at 3, as we approach from the left, right, we're going to be getting like 2, 2.5, 2.9, 2.99. So let's plug in here, right? Let's plug in, let's say like 2.999. Let's just go to 3 decimal places. It doesn't really matter, okay? But notice what happens. We get 2.999 minus 5 over 3 minus 2.999, okay? The numerator becomes negative 2.001. Denominator becomes 0.001. Right? We're not really worried about the actual numbers here. What we're really concerned about is the signs. The numerator is negative. The denominator is positive. Okay? If you actually divide this out, we get like negative 2001. Just move this decimal point 3 times over. Okay? The key is that it's negative. It's a pretty large number in the negative sense. So we can get closer and closer, right? We can plug in like 2.99999 or 2.9999999, right? The number is going to get really large in the negative direction. So what does that mean? It means that this limit, as x approaches 3 from the left, the limit is negative infinity. Okay. So let's do the same thing, but as we approach 3 from the right-hand side, okay, of x minus 5 over 3 minus x. Okay, so same idea, right? Let's just plug in as we come in from the right side, right? Let's plug in, probably we'll do 3.001, right? We'll go 3 decimal places again. So 3.001 minus 5 over 3 minus 3.001. Okay, now, once again, the actual number doesn't matter, but here we get what, like negative 1.999 on the numerator. Denominator, notice we get negative 0.001. Once again, we're not concerned with the actual values, but the numerator is negative, the denominator is negative. That ends up being a positive, right? In this case, 1099. So similar idea, right? We can get closer and closer to 3. Like we can plug in like 3.0000001. Okay, this number is just going to be like a really large positive number. So what does that tell us about this limit? As we approach 3 from the right, this limit is positive infinity, and that is the behavior of our vertical asymptotes. Okay. Finally, we find the limit as x approaches infinity of this function. And the method we learned was, well, we look at the denominator, we'll look at the highest power, in this case is x. So we're going to divide everything by x, right? So we got x over x minus 5 over x. We have 3 over x minus x over x. These just cancel out, right? So we got the limit as x approaches infinity of 1 minus 5 over x and 3 over x minus 1, right? X over x there. Okay. Now we can use the limit laws to take the limit of each term separately, right? So I'm not going to write everything out again. We get 1, 5 over x, right? As x goes to infinity, that's just a 0. Same thing, that's just a 0, that's the negative. So we get 1 over negative 1, which is negative 1. So what does that tell us? Right? The limit as x approaches infinity is negative 1. Okay? And in this case, that's actually going to be the horizontal line, right? That is going to be the horizontal asymptote.